Hello everyone. In this video I'll be talking about two scripts that are written in VBA for solving differential equations numerically. The first example we're going to look at is the three species problem, the reaction equation we solved I think in the last lecture using forward Euler. And in the next example we're going to look at a third order differential equation. So something that we can convert, higher order differential equations to a linear system of differential equations. Okay, so if you remember, we got this VBA code. Basically our template is what is given in the textbook. It's the VBA code provided in example 5.7. So we're going to modify that to be able to solve the three species problem. Three species problem is example 5.5, right? So we're going to solve this now, this time using VBA. We solved this before using spreadsheet, but we're going to do it using VBA now. Okay, so I'm just going to jump directly to the VBA script. This is the VBA script for three species problem. And most of the script is actually taken from example 5.7. I'm going to modify it such that we can solve the three species problem. Okay, so before we actually solve this, I just want to remind you that if you want to solve this system, right, if you remember, we converted the three equations we had in using forward Euler. So the first equation is the forward Euler version of the first, the second one forward Euler version of the second equation, and the third is the forward Euler of the third equation. So this is covered, I think, in one of the last videos. I really encourage you to go back and look at that if you don't remember what we did from here, from equation 5.32 to these set of linear equations. Okay, so all we do is we need to code these three equations into the VBA script that we got from example 5.7. So this is the basically VBA from 5.7 with a little bit of modification. So we're going to introduce y and f as before. So this is exactly from example 5.7. We haven't changed anything yet. H is the delta t. T1 is intermediate time, maximum time, current time. The current row number and I and n are two integers. Okay, so we're going to activate the sheet. You're going to read the number of unknowns or number of variables we're going to solve for from the spreadsheet. This is cell 1-1 here. So right now we have three unknowns, the concentration of A, B, and C. So that's why n is 3 on the spreadsheet right here. We're going to read it from there. Then we're going to redimensionalize our two vectors y and f to have size n. Okay. Then we're going to activate. We're going to go to the sheet and read the delta H value, which is from cell 1-3. I move this over. Cell 1-3 is this one, so we're going to read delta T from here, or H. Okay, we're going to read the time max and time as well from cell 5, and so maximum time is from cell 5 here, row 1, and then the current time from cell 3, column 1. So this is the current time, 0, right? So we're going to pick up this 0 to begin with. And then we're going to go over the loop and start iterating and reading the initial values. Okay, so we go to cell row 3 and then column 2, 3, and 4 because n is 3. So we're going to go to row 3, column 2, 3, and 4. We're going to read the three concentrations, the initial concentrations. They all go into y vector. Then we're going to increase the row number. We're going to go to row 4, and this is where we have to calculate the concentration and print out. So from this point on, we have to iterate as long as our time is less than maximum time. So once we reach maximum time, we have to stop, and that's what this while loop is for. So it's going to check whether the time is less than maximum time in every row. So every row actually we do all these lines. So the first thing we do for every row is we calculate the y and f. And this is done by calling function fcalc3, which is down below here. Okay, so in here I hard-coded the kinetic rates or the reaction rates. Let's say these are the rates we have. I just manually put them in there. If you don't want to put them in there, then you have to bring them to the argument list here. But let's say we hard-coded them here. And then we write the right-hand side of all three equations right here. So the right-hand side of the equations are, well, this, this, and this, right? So these three are written here. So minus k1 times now. There's a little bit of detour. Move this over here, and here's the script. So it's minus k1 times CA, and here's minus k1 times now. CA is going to be the first element of y, and then CB is going to be the second element of y, and then CC would be the third element of y. Okay, that corresponds to CA, CB, and CC. Let's look at the second equation. K1 minus K2 minus K3 plus K4, and this is it. K1 minus K2 minus K3 times CB, and then plus K4 times CC. The last one is K3 times CB minus K4 times CC. And that's exactly what we have here. So all I did in this function, I implemented the right side of the three equations we had. Okay, so then when this function returns, we're going to have new f value, and then we do the forward Euler. The new y value would be the old y value, or yn plus 1 is equal to yn plus h times right-hand side f at time n, because we calculated in here. So now we have the f, we have the old value of y. We're gonna calculate the new value. This is going to be yn plus 1, and then after we calculate this, we have to put it out on the spreadsheet. So that's why after this loop, after we calculate the y, we're going to increase the time by delta h. Immediately put this time on the spreadsheet on ACK row, so right now it's going to be in row 4. And then we're going to put the y values on the same row and the next three columns. So the same row 4 we're going to have in column 2, 3, and 4. We're going to print out the corresponding y values, which could be concentration of A, B, and C, the three elements in y. And then we increase the ACT row by 1. We go to the next row, which is row 5, and repeat the whole process. This process is repeated until time reaches time max, and that's where we stop. This is it. So with this code, we can run the VBA script and solve the three species problem. Now, to let you know how we can do this, I'm going to delete the result from before and run it right here. So here's the code. And just go to run, reset, and run. There you go. So it solved all of them with the increment of 0.1 all the way to 10, and here's the plot. This is second column versus the first, which is CA. This is CB against time, and this is CC. Okay, so this was the three species problem. The next problem I'm going to look at is the third order differential equation. Let's say we have a differential equation like this. Okay, this is basically an extension of example 5.7 of the book. We are using that VBA to solve this problem. Let's say I have a third order differential equation like this with alpha, beta, and gamma, three constants, and I have three initial conditions. At 0, I have y0. At 0, I have y prime 0, which is the first derivative of y. And then at time 0, again, I have now this time second derivative of y. I have three boundary conditions, or three initial conditions, one equation, but it's third order. Okay, so we remember that we can convert higher order derivatives into a system. And this is following the technique we learned from section 5.6 of the book. Okay, so this is what we learn, how we can convert a second order differential equation to a system. Remember that we had the new variable z, right? Okay, and if you don't remember this, I really encourage you to go back maybe in the last two videos and look at how we converted higher order differential equations to the system. Okay, so let's go back to the equation we have. Now to convert this, I assume y prime is a new variable, and then y double prime is also another variable. If I assume that these two are two new variables, then I can write this third order equation into a first order system. So this is just d dx, I don't have higher order. This is a new variable, and I know that dy prime dx is y double prime, but y double prime is also a new variable. And dy double prime dx is y triple prime, which is, from this equation, is, so y, the third derivative of y with respect to x, or y triple prime, is going to be minus alpha times y double prime minus beta times y prime minus gamma times y. Because if the sum is 0, this term is going to be negative of the other terms. And that's what I have here. So we're going to call this, let's say, z and another variable, and then we just write this set as a first order system. So let's see how we can do it in VBA. Yeah, I have the equations here. These are the initial conditions, right? And I have alpha, beta, gamma. And these are the constants of the problem, if you remember. Alpha, beta, gamma, right? So these are just the constants for the problem. The only thing is how we implement the three equations in here. So let me go back to the third order. The third order differential equation. So this is the code for it. Pretty much like what I explained for the three species. I'm not going to go over them because that's the same thing. Maybe this thing is just to clear the previous result. So it gets the last row and then it clears them up from cell A4 to cell C, or the column C, last row in that column. Alright, so the only difference here is, actually the only difference compared to three species problem is we read alpha, beta, gamma from the spreadsheet, right? Column 7, 9, and 11 of first row right here. So we read these constants, and then the rest is the same, nothing has changed except this function. So instead of calling the function we calculate the right-hand side of the three species problem, now this time we're going to call another function, and we calculate the right-hand side of our equations. The right-hand side would be y prime, y double prime, and this minus alpha times the rest of it. So that's what I have here. Just remember that y prime is going to be the second element of this y vector. This is the y vector. Y prime is the second element of it, and y double prime is the third element of it. So I rewrite those three equations in this form. The first, the right-hand side of the first equation is the second element of y. The right-hand side of the second equation is the third element of y, right? Second element of y, third element of y, and this guy, which is going to be minus alpha times the third element, minus beta times the second, minus alpha times the first. And that's exactly here, minus alpha times the second element, minus beta times the first, minus alpha times the third element, because y double prime is the third element, minus beta times the second element, and minus alpha times the first element of y. And that's what we have here. There you go. So the only change would be, I think, these three lines and reading alpha, beta, gamma from the spreadsheet. Nothing else. Everything would be the same as the example 5.7 of the book or three species problem. So let's run this. I'm gonna clear this up and go back to the script, reset, run. There we go. By the way, this should be, well, I think I think the initial conditions need to be, let's see, I think the initial conditions I had was, well, times 0 here, and I believe 1, 0, minus 1, something like that. Yes, 1, 0, minus 1. Okay, so this script is on Blackboard. Hope you enjoyed it. And stay tuned for the next example on VBA.